My name is Adrian Knox, and this research concerns the recycling of neodymium magnets. I started with a hard drive cover so I could protect the inside of the assembly from heat. The goal was to remove this sticker and expose that central spindle screw you see there without heating up the inside. You can see that we're at about 40 degrees Celsius there, which is acceptable. We do not want to heat those magnets up on the inside because they will degrade, and that's why we took the precaution of just using the cover. That's the first step. Now I am disassembling the hard drive so I can pursue the secondary goal, which was to find out how to disassemble the magnetic assemblies. Eventually, this entire process is going to be automated. What we're doing is investigating how to separate the internal magnetic assembly, which I'm getting to here, manually, using various processes. We're looking for the best process to separate those assemblies. So you'll see the assembly in a second. This step right here of me manually taking apart this hard drive would be accomplished by a machine finding that central spindle screw that we exposed underneath the sticker and punching it out, punching the magnet out, because the magnet is within a certain distance of that central spindle screw. So there is a magnet coming out. You can see that it's very, very strong.
The other half is still in here.
And in the final machine, that would be taken care of on a assembly line or disassembly line by a punch. It would just punch it right on out. There's various geometries to these hard drives, so that's another challenge, is finding out how to do this with one machine. So there's the assembly, and you can see how powerful these magnets are, because they will just jump.
Whoa.
And they're quite powerful. So getting them apart after they're stuck together is a challenge. You can see I'm 275 pounds, 6'4", and I go to the gym every day, lift weights, and I can't get these little magnets apart unless I twist them in just the right way. So there they are. There's two sides. They're kind of mirror images of each other. After we access the magnetic assemblies, we measure the magnetic field on them, because the various processes that we use actually damage the magnets, especially heat. There's something called the Curie temperature, which we want to not reach as we are separating these assemblies. Now that assembly there's a back piece, permalloy is what it's made out of, and then there's the actual magnet. So I'm going to show you how to separate the two. So this is the mechanical method. You can see that the magnet was held up while the permalloy was allowed to slide down. And now this is something that we tried to avoid, is the glue that's binding those two things together is so strong it will actually
There we go.
take off the nickel plating on both the permalloy and the magnet, which is bad. So we use various other techniques, including ultrasonic baths. With a particular solvent, we use the 3M adhesive remover solvent, which is inside the metal container. The rest of that liquid is water, as dictated by the operator's manual of that particular instrument. Also, here's an oven, and this is how we are actually able to, the oven in conjunction with the mechanical method provided the best results, because we did not have separating between the nickel plating and the magnet. The nickel plating was intact, and the glue was softened up just enough to be able to remove them using the mechanical method.